I'm Woodday Snyder. I am the founder and CEO of Gizzle Technologies, and we are building the software capabilities for our device developers that allow them to incorporate the sophisticated and security features into their products really quickly and easily. So there are a lot of devices out there where they have well understood security requirements, but one of these foundational security capabilities is Secure Boot, which is required to make sure that the kernel is your software before you allow it to boot. So being able to verify it with a key that is protected by a hardware root of trust allows you to build this execution integrity starting from this hardware root of trust, validating the kernel before it boots, and then building upon that to build that secure execution chain. It also needs to survive through updates. After you update your software, you want to make sure that that secure execution is intact. So being able to validate that the friendly update came from where you expect it to. Again, protected by the IGNs and your hardware root of trust allows you to update or advise and still remain confident that the integrity is preserved. Additionally, this creates operational challenges around firmware management, firmware signing and key management. So we have a firmware signing service, we've got management integration, we've got the update management service so that you can manage these devices in the field. So that all those capabilities work together to provide this system that allows you to protect your software supply chain for your devices. We actually can support all kinds of systems, but right out of the box, it's very easy to support a lot of different systems that are running Linux. And we support a bunch of different bootloaders. And we have a set of, at CSI also, some more. It was actually a really cool demo that Doobie doesn't.
Okay. And you win this prize from the Best in Show Award Embedded Ford.
Yeah, we're very excited that we were chosen to receive the Best in Show award. I think it's because they recognize that the problem that we're trying to solve is very widespread. A lot of people are struggling with it, and that our solution allows device developers to reduce the timeline for deploying this capability from 12 to 18 months to a matter of weeks in a lot of cases. So we're thrilled to have been chosen as the winner.
Okay, so here we have our platform. We have multiple releases for various different systems, and our demo we will start by triggering connecting to the Wi-Fi. And because we are at Embedded World and there are so many people, I'll use my hotspot to connect to the internet. Just give me a second. And there we go. So the first attempt to connect to the hotspot obviously failed because it's too busy. But there we go. We have connectivity and we're trying to connect to the server. We're pinging our TISO servers so we can see they're well and alive. And here we have all the devices that were previously connected. We had a test with Yana, with Felix, and now with you, Boris. So after we check that our servers are good, we are enrolling. This means a new device will show here in a moment. Bam, that's our new device. And we're using the hardware ID, the hardware identifier that's burned by the manufacturer in the device, in the PSOC6.
Like MAC address?
Yes, exactly. It's unique and it's burned to the hardware. And you use that. And when we use that, we get a device token from our cloud platform. This device token is unique. We cannot know what that is. Only the device and the cloud, and it's encrypted. So if this is lost, the device has to be onboarded again. So this is very special and it's saved on the device. Using that device token, we know that this device is allowed to fetch the latest release. In this case, the Embedded World demo. And on the Embedded World demo, we see that we have a started event. And in the assets, we can see the update with its signature. And here's the download location.
Yeah.
Here's the signature for verification. We have the name of the current release, and we have the hash for further data integrity.
So I'm sure that is my board, and nobody is try to hacking it.
Yes, and the manifest is genuine, so we're downloading the new release, and right now it's downloading and flashing the new release to the board. So before we had a main user application here that was not detecting movement. It's a machine learning model that was not detecting movement. In a moment, we'll have a new machine learning model that will detect the up and down swings. You can just, in a moment, you first will send a notification. We will send a notification to the system, to the cloud, that this it's a successful update. Of course, I can show you also failed attempt when something goes wrong. And now that the update will be complete, I'm starting to do an up and down move. And the new machine learning model was able to detect the up and down move. And if we go here again to the status, we'll see that we had a success 11:18 a.m. But if you scroll down, wait, this is only the you see that,
Okay.
yeah, we see that there were also failed attempts, right? So, and the good thing about our platform to complete the journey is that you can have a signed firmware update here. You don't have to worry about it. You just give us the update, we sign it for you, and then deploy to all your fleet.
And I can connect SC Infineon, but also SC other board.
Yes.
There's a limitation.
There's no limitation. We can do bare metal for industrial and medical. We can do RTOS and Zephyr, and we can do Linux enabled devices like NXP and Qualcomm.